Okay, am I good to go?
Yes.
Okay, this is the Ijamsville phyllite. It's somewhere on the boundary between a slate and a phyllite. I would call it a slate, but it does have a little bit of a shine to it, and that's the sign of a phyllite. It's called Ijamsville phyllite because in this country, rock units are almost invariably named for a geographic location where you can see them. The town of Ijamsville is basically a small village here in western Montgomery County, and it was named for that. The rock itself is extremely uniform. I have never been able to find any sign of bedding here. That lack of bedding is an indication that this environment was very, very constant. It did not change from day to day, from week to week, from month to month, from year to year. Very much the same all the time, which is a sign of deep water deposition. When this is called a deep water sediment, that is the evidence for it. If you can come up with something else, you're welcome to try, and you might be right. It's not something that is absolutely positive. Also, the age. This is probably Ordovician, but that's basically it's not quite a wild-ass guess, but it is just an educated guess. There is no good date on this rock at all. There are no fossils in it. There are no fossils that have been found anywhere in this area. And the nearest fossils to here are quite a few miles away and separated by some major faults. And probably to the west of here, there is absolutely no relation between the rocks here and the rocks, say, 2 miles to the west of here. They're in what are called completely different terrains. A couple of miles down the road is a major thrust fault called the Martic Line. It's called a line, by the way, rather than a fault, because when it was first noticed, they saw that the rocks on one side of a particular line that you could draw on a map were all shallow water rocks with good bedding in them. The rocks on the other side were very uniform, deep water rocks that had a lot of carbon in them, indicating it was a deep water rock. They had no idea what the relationship was between them, but since they could draw that line, and since that line could be seen in the village of Martic, Pennsylvania, they called it the Martic Line. Since then, geologists have determined that it is a major thrust fault. It's an early thrust fault in the history of the Appalachians because the fault itself is very tightly folded. So here we have a case where the deep water rocks were pushed up and over the rocks to the northwest in a shallow fault called a thrust fault. And then the whole package, the above and below the fault and the fault itself, were tightly folded. That we believe happened it obviously happened later. We believe it was much later, like a couple of 100 million years later, at the end of the Appalachian mountain building period. This fault, we think, happened at the very beginning of the Appalachian mountain building period. Okay, the mountain building period itself can be studied a little bit easier, a little to the west of here, where the rocks aren't quite so badly messed up. And the sequence that we find is that there's a very thick section of rocks that predates the Paleozoic entirely. Very, very similar to the rocks that you find, say, in the Gulf Coast or the Atlantic coast today, the coastal plain sediments, that are typically deposited on the very edge of a continent. It's called a passive continental margin. It's a continental margin where nothing really interesting is happening geologically, except that you keep depositing more and more sediment along the edge. At the early in the Paleozoic, this changed because the Atlantic Ocean started closing. And when it started closing, there was a volcanic mountain range that was formed off the edge of the continent, very much like the island of Japan today, or the islands of Indonesia, with volcanic rocks and violent eruptions of volcanic ash. And then that volcanic island was shoved back onto the continent. And that shoving back onto the edge of the continent was the motive force that pushed these deep water rocks over the shallow water rocks. So it's the first sign of interesting things happening on the edge of the continent. Now, we don't see any of the volcanic rocks right here. They were further to the east. But you can see the effect of those volcanic rocks all the way into the interior of the continent. For example, in Kentucky, where I went to graduate school. Because what we find there, rocks of what we think are this age, as I said, the age is a little bit sticky, but our guess is that rocks of this age, which in Kentucky, which can be dated very nicely because they're full of fossils, they're limestone, almost pure limestone, because there was nothing much going on nearby geologically. Except that you do find layers of clay, very thin layers of clay, a few inches thick, pure clay, called flint clay, that turn out to be volcanic ash beds. These volcanic ash beds were from the volcanoes off the edge of North America that were carried hundreds of miles by the prevailing winds inland and then deposited in the shallow water, which was then Kentucky. We know that it was a volcanic ash because they do contain tiny crystals of quartz, of a very high temperature type of quartz. You can identify it by the shape of the crystals, and this is very typical of volcanic rocks. They're found only at very high temperature. Very tiny, but they are there. Okay, so that is the slate that you find here. Of course, Slate Quarry Road is a hint that this quarry was here. The other interesting thing is over on the side there, you can see there are some white rocks. I've got a piece of it here. Here we go. This is vein quartz. There's a little bit of slate still attached here, and this is almost, well, as far as I can see, it is pure quartz. And quartz is almost completely insoluble unless you get very, 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 very hot water. Very, 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 very hot water will dissolve quartz, but then as it cools off, it loses the water and deposits pure quartz. So what happened was that this rock, which is a metamorphic rock, was buried deeply enough to grow new metamorphic crystals in it. And then some of the water in the rock was forced out during the metamorphism when this was deeply buried. That water dissolved some quartz, was carried upward to where it began to cool down, and when it began to cool down, it deposited the quartz in breaks in the rock, which is the white rocks that you see here. Now, right here, it's only pure quartz. We are still in Montgomery County, and similar rocks can be seen along the Potomac River, near the town of Potomac. And in that area, the quartz veins are more interesting. They contain gold. There are gold mines there. Now, they are not being worked today because early in the 20th century, gold was worth $35 an ounce. And it turns out that they got too expensive to mine the quartz veins with the gold in it, and it was costing like $50 an ounce to get the gold, in which case you no longer have gold ore. Ore is defined as rock that you can make a profit on, and you can't make a profit if it costs more to get the gold out than it's worth. Now, today, I think last time I checked, gold was somewhere between $1,500 and $2,000 an ounce. Today, if those quartz veins were in Montana or Nevada, they would be mined. There would be active gold mines there. Well, the gold is worth just as much here, so why don't they mine it today, here? Well, there isn't much gold in the rock. You can get it out at a profit, except then you're left with thousands of tons of waste rock from which you've taken the gold out. What are you going to do with that rock? Just dump it? Where are you going to dump it? In somebody's backyard? Well, it turns out that you can't dispose of the rock here in Montgomery County very easily. You would have to ship it out to somewhere else, which would be very expensive, which means that the price is now much higher than the value of the gold. I tell my class sometimes that there are indeed gold mines in Montgomery County. They're called real estate offices. The real estate is worth more than the gold is. So anyway, that is what you see here. Now, we are on the North American side of the old ocean. When we started out in Tacoma Park, the bedrock there, which can be seen in Rock Creek Park, is, we believe, African in age. It's not North American at all. It was on the other side of the ocean before the continents collided. The evidence for that actually can be seen in this area, in that the rocks here were not really disturbed. They weren't folded, they weren't faulted, they weren't metamorphosed until about 450 million years ago. You can't get that date right here, but there are places in this area where you can get radiometric dates which pin down when the deformation took place. And although it did take place long ago, like 450 million years ago, in easternmost Montgomery County, like Tacoma Park and Rock Creek Park, the deformation there was taking place on the order of 600 million years ago. All hell was breaking loose geologically then. The rocks were faulted, the rocks were folded, then the folds were faulted, and the faults were folded. All hell, as I say, was breaking loose. Wait a minute, that's 25 miles from here? How do you have all hell breaking loose there and nothing happening here? The answer is there was an ocean in between them at the time. We don't know how wide the ocean was. It might have been a couple of thousand miles. So the rocks in eastern part of the county and the rocks in the western part of the county have no relationship to each other originally. As a bit of supporting evidence for that, by the way, if you go east of here to Rockville, which is about halfway between here and Tacoma Park, there are exposures of serpentinite rock with some asbestos in it, and that is a remnant of the ancient ocean itself. So we have the rocks from the eastern side of the ocean colliding with the rocks from the western side of the ocean, and a little bit of the original ocean rocks caught in between. Just fragments of it, bits and pieces. It's badly messed up and very difficult to figure out, but it is present there. Okay, we'll leave it at that and get on to our next stop.